Hello, everybody. This is Amy Katie from New Relic. Welcome to our first customer webinar. First, want to introduce Michael Redmond, who's with us. He's one of our systems engineers who's actually going to be walking you folks through the product. We also have on the call Steve Hudson, who's our director of that team, who's also going to be helping facilitate with some questions as well. So, if you are all muted right now, so if you have any questions or you're having trouble hearing us, please just send a note to me in the chat, and I will try to address those as they come through. If you have a question that relates to something that Michael's talking about, you can raise your hand and I can unmute you and you can ask the question. We're going to pretty much make this informal and try to get as much information to you folks as possible during the next 30 to 45 minutes. We'll also have an open Q&A at the end of the session. And again, if you want to just type in your questions in the chat and we don't get to the answers, we will commit to following up with you this week or early next week with either a call or an email to answer your questions as well. Without further ado, I think I'm going to pass this over to Michael and we're going to get started.
Hello, everybody. This is Michael Redmond here. So I guess the goal for today is to make sure that you folks really understand the data that we're gathering with New Relic. To make sure that you understand the 3 core components that we use to monitor. Also to make sure that you understand what Apdex is. A lot of times we get questions around Apdex and what it is. I'm going to describe that a little bit. But then I also want to go a little deeper and give you some more insight into a couple of configuration items you may be able to work with to get additional data out of New Relic. But first I wanted to start off with just talking about the New Relic solution in general and the 3 core components. And the first core component of our solution being obviously the application monitoring. Okay. The second component being server monitoring, looking in depth at what's going on your servers as far as CPU, memory, disk utilization. Now, a question that I had is, everyone using server monitoring today? I think Amy has a poll that she's going to put up. Not sure if it went up or not.
I just posted it, yeah.
Okay, so you have some answers coming in. And unfortunately, I can't see the answers that are coming in. Okay, and then finally, the third component, which is the real user monitoring. So those are the 3 core components of New Relic. We feel that for a complete APM solution, it really is necessary to have all 3 of these components. We need to understand the application, we need to understand the physical host, and we need to understand how the end user performance is as well. Okay, so just quickly to cover the architecture, I'm sure that your folks are familiar with deploying the agent. Hopefully it was a pleasant experience deploying the agent. Kind of pride ourselves on making the deployment very straightforward and simple. So the first thing that you do with the New Relic agent is you deploy it out to your application servers. And an important note is we support 5 languages. We support Java, .NET, Python, Ruby, and PHP. So a very important note there is the language support. In addition to the languages, you can also deploy out the server monitor that I just mentioned. So from a server and application perspective, we're able to get those 2 different data sets for you. Once you've deployed out the agent, we're going to send that data back to the New Relic data center over a secure connection. And that's it. You're up and running with New Relic, and you should start seeing data right away. Now, the third component I mentioned earlier was the end user data, or the RUM data as we refer to it. The way that we get RUM data is that based on the frameworks or the languages that you're using, we're going to inject a small bit of JavaScript, and that JavaScript is going to make it out to the end user's browser. Once that JavaScript has been loaded within your web pages, we're going to grab metrics about how long did it take to get data across the network, how much time was spent in my application, how much time did it take to load my pages. Then that data is going to be sent directly back to the New Relic server. So we're not going back to the application incurring any additional overhead. And then finally, you as a New Relic end user are going to log into our UI over a secure connection, and you're going to go ahead and work with your data and run your reports. So that's just the basic architecture. And now I'm going to talk about the couple key concepts that we'll mention. And I'll mention these as I go through the presentation. Talk about enabling request parameters. What will that do for me? Custom metrics. What does that do? Looking at what data obfuscation is, deployment markers, and availability monitoring. Okay, these are not all turned on out of the box. That's why I think it's important to mention them because there's a great deal of value there. Okay, now we'll go into the demonstration. And hopefully everyone can see my screen okay now. So what we're looking at here is the New Relic dashboard. We have a list of all the applications that we've deployed the New Relic agent out onto. And you'll notice that we have a lot of information here. We have information about end users. We have information about the application server. And you'll notice here that we don't have end user data for some of these applications. That's purely because these applications don't have a UI that end users interact with. It's important to note also that this is our New Relic infrastructure that you're looking at. So when you log into New Relic, this is the tool that we're using to monitor. So we use New Relic to monitor New Relic. Okay, on the right-hand side here, we have the recent events. I think of this as a Twitter feed. This is about everything that's going on within my application. Whether I have deployments taking place, if I have alerts that are being raised, or any critical events, those are all going to bubble up here. And this recent events is nice. It shows up on all overview screens. Okay, so here I can see on average my app server is performing at 30 milliseconds. This is over the last 5 minutes. I can see my throughput. I can see my error rate. Where I'm going to start with New Relic, I'm going to start within the application server. Let me just take a second to drill down here. Before I go any further, I want to just kind of get the lay of the land for you. The nice thing about New Relic is wherever you start, you're going to always end up in the same place. The goal is to show you where you're having performance issues and to get you there in as short as time as possible. So when we look at the menu here, we're looking at the end user data set and the app server data set. I think it's important to note that all the data for those two columns is all average and aggregate. So if you have multiple servers with New Relic deployed on it, when we're looking at the data in any of these two views, it's going to be all your servers on average and aggregate. When we drill down and want to look at specific instances of transactions, that's where we're going to go ahead and drill down into the diagnostics component. But as I mentioned earlier, the nice thing is we can start with the app server and we can drill right down into the diagnostics. It'll just take us there. Okay, and then we have a bunch of reports available to you as well, and I'll cover a few of those reports as we move on through the presentation. So I'm going to go ahead and drill down into my overview. I think at this point, it's a good time to stop and explain what Apdex is. You can see Apdex is going to be prevalent throughout New Relic, whether it's building alerts or just looking at the overall satisfaction of an end user. I have a slide here that explains how Apdex works. Now, Apdex is something that New Relic didn't invent. It's an industry standard. And essentially how it works is it takes data samples and places them into 3 buckets: a satisfied bucket, a tolerating bucket, and a frustrating bucket. Now, the way the data samples get placed in those buckets is by the t-value. I think of the t-value as kind of the linchpin of Apdex. You define the t-value. In our case, it's defined to 1 second. And that's basically saying that any response to a user within 1 second is deemed as a satisfied user. Now, you have to do a little bit of math to get the 4 t-value. So that's t times 4 is going to give you the upper threshold. So anything between 1 second and 4 seconds is deemed as a tolerating user, and anything over 4 seconds is deemed as a frustrating user. The key about frustrated users is that if a user is frustrated, a lot of times they don't come back to the site. And the math is very simple for Apdex. Take the number of satisfied users, you give them full credit. You take the number of tolerating users, you give them half credit. And then you take the frustrated users and you just throw them out. And then you divide everything by the total sample. So the nice thing is we take the throughput into account to normalize the data, and that gives you your Apdex score. 1 being a perfect score, and 0 being a place where you probably don't want to be. We here try to keep everything above 0.85. Okay, so now we have a little bit better understanding of what Apdex is. We can go ahead and drill right down into the application server itself. So we can see over the period of the last 60 minutes here on the right-hand side, and I can change this. From this screen, I can go right up to my last 3 months, or I can go over a historical time period if I had an outage in the past or I had a performance issue, and I can drill down into that specific time range. So on average, my application is responding within 224 milliseconds. Let me just close this window over here. Okay, and you can see the type of data that we're grabbing. We're grabbing different components from the application server. This application that we're looking at here is written in Ruby. So Ruby is going to give us information about garbage collection. It's going to give us information about how much time was spent inside the Ruby VM itself. Now, when I mouse over any one of these graphs, you'll notice that I have a hovering window, and it gives me information in context about what I'm looking at. So I can see over this 1 minute period from 10:44 to 10:45, on average, my requests are being served up in 119 milliseconds, and I have close to 7,000 transactions in that 1 minute time window, and that's specific to the time spent within Ruby. On the right-hand side, you can see my aptX score. We're considered to have a good aptX score for this particular window. And as the graph updates, if I continue to scroll, I can also see my throughput in context of the minute window that I'm looking at. So up here on the right-hand side is our aptX score. We've set it to 0.4 or 400 milliseconds. By default, the aptX score out of the box is going to be half of a second or 500 milliseconds. That's something we do encourage you to change over time. It will help you to continuously improve the performance of your application. Okay, and right now I can see my aptX score again is running at a 0.92, which is considered to be good. Okay, another note is the slow transactions. As I mentioned earlier, New Relic, we look at everything that comes through, but we only want to show you the information that's important. Now, the way we calculate slow transactions, again, is based on aptX. It's going to be on the T value that you define, okay? And any transaction that is slower than that T value for any given minute from any agent that's deployed is going to be bubbled up here. And from here, I can drill down and look right at a slow application, or excuse me, a slow transaction. Also, we're capturing all the non-handled errors. So if there's errors occurring outside your exception handling, those are going to go ahead and show up here. And again, we can drill right from our application overview down into specific errors and error rates. Another important note is that we understand that there's 3 different servers that are supporting our application. Now, the data we're looking at here comes from our server monitor. And that's the reason I asked earlier if you folks had server monitoring deployed, is because I can see, again, on average and aggregate how my application is performing, but then I can go ahead and drill down into any one of my given servers. Okay, so as I drill down into my server, now I'm starting to look at information for a specific server, and it's going to give me information about how many CPUs I have, how much memory I have, what OS I'm running. It's also going to give me information about my network I/O, my CPU utilization, my load average. And again, a nice thing is whatever I hover over, it's going to highlight all my graphs so I can kind of look at everything in context. The reason I think this is important is because you may have processes running on a server that are not related to your application that are adversely impacting the application. And from here, I can go ahead and drill down into any one of these processes. So if I tap on the Ruby process as an example, it's going to go down one more level and show me Ruby, show me my memory consumption, okay? And if I stand on any one of these other processes, the graph's going to shift within context and show me my CPU, my memory, and my running instance count. Okay, so hopefully you can see the importance of having server monitoring deployed so we can tie what's going on an individual host back to what's going on in whole with the application. Are there any questions? Yep.
I'm actually addressing them in chat.
Perfect.
So yeah. So yes, please, if you have any questions or if you want to actually ask the question, just let me know and I can unmute you.
Sorry, I clicked the wrong button there. So back to the overview screen, there's a couple other nice areas that we can delve into from an application server perspective. One of them I particularly like myself is the map. I want to understand what outbound calls I'm making and what inbound calls are coming. So I can say I have end users that are accessing my application. It shows me a little bit of information. I have 3 servers. If I pop down the window here, it's going to show me a graph in this context of the last 60 minutes. So I can see that my application is going out and talking to my database. And when I hover over any one of these charts here, it shows me similar information as we saw on the last screen. It shows me over this particular minute, my average response time. It shows my call count and my max and min times. The way this graph works here is the thicker lines show that there's more throughput going to that particular service or that particular database call. And another nice thing is if I'm making any external calls, in this case we're making an API call out to Heroku, I can see is that adversely impacting my application as well. The next area I particularly like to look at is the web transactions. Now, the thing about the web transactions, these are going to be defined by the different types of frameworks you're using. So in the world of Java, if you're using a Spring framework, or if you're a PHP shop and you're using Drupal or WordPress, we define these names based on what we know about the framework. Okay, so that's how we're getting these names on the left-hand side here. What we're looking at here is the top 5 transactions, total percentage of total wall clock time. What I can do here, though, is I can start to sort this information. I can start to look at what's the slowest average response time for my application server. And when I see that, I can see it's this admin user's controller, okay, the new controller. So if I highlight that controller, my graph is going to shift in context to this specific controller. And that's important to understand. The data that we're looking at here, again, is all average and aggregate data. Okay, but now I'm looking at it for a specific transaction that's been generated from the agent. Okay, I'm going to pick on a different one of these controllers here, the show controller. Okay, and again, I'm in context over the last 60 minutes. I'm actually going to change the time frame. I'm going to go back maybe for the last 24 hours. We might have some more interesting data to look at. And let me just see if I can find one that may look interesting to us here. Okay, so now I can see for this specific, which is our index controller, I can go to the performance breakdown. Now the performance breakdown is going to show me what's going on from a component perspective. So now I'm starting to peel the layer of the onion back one level deeper. So now for this specific controller, these are the different components or segments that are being called for that specific controller. Okay, so at this point, I know that I may be having a performance issue with this controller. I can go ahead and drill down into one of my slow traces, again, which is based off of the t-value defined within Apdex. And now I'm into a very specific instance of my controller. So what we're looking at here is a summary of the trace details. Okay, again, it's going to show at a very high level the different components. Request parameters is something that I mentioned earlier I was going to talk about. By default, they're not turned on. I think they're very helpful to turn on. The reason for that, if I do have a consistent performance issue, if I'm having the parameters that were passed into that request listed for me, I can always pass those parameters back into the request to see if I can produce that same performance issue. I also mentioned custom parameters earlier. Now, custom parameters are something that you need to do a little bit more work to get, but they may be extremely helpful to you if you need to extract items that are coming through the application, going through your code base, and bubble those up to the top to help you. Again, the intent is to help you, if you're having a performance issue, to reproduce that performance issue or to help you debug. So now from a summary perspective, I'm going to go ahead and drill into some of the details of this particular trace. Okay, so I can see in total that this took approximately 14 seconds, we'll say, I can round it up. And I can start to see where the time was spent based on this waterfall chart here. Okay, I can see that this one particular find by SQL took contributed about 15% of the overall call. And we understand that there was a slow query associated with that, so I can drill down and look at what that database query looked like. Okay, if I scroll down a little bit further, I can see from this particular request there's a lot of database queries being called, and each one of them is taking on average about a second and a half. So if I'm making a lot of database querying, I can start to deduce that a request that makes a lot of calls is obviously going to be slow because it's doing those repetitive calls. And I just wanted to point out this application code, because this is something, as a new user to New Relic, you may see this. And what the application code really means is that we stopped our instrumentation at a certain point. And there's several different reasons for that. There may be something we don't understand about the framework. If that's the case, we can always grab additional information. It may be that the code is just executing. Maybe you got a result set back from the database and you're looping through the data and working with it. So when you see the application code, there could be a couple different reasons for it. There's very good documentation on about how you can get one level deeper if you, in fact, do need to get one level deeper. Okay, as part of this request, we know that there were several SQL statements called. Okay, we're only showing 3 here. If I click on the less than 5 milliseconds, it'll probably blow up and show us a lot more. Okay, so we know that this one request talks to the database quite a bit. And again, from here, I can open up my database query. This one particular database query is a little bit more interesting. If you're using SQL Server, if you're using MySQL or Postgres, we're going to offer a query analysis or an explain to you lower information about what's going on with the database. Okay, we're also going to show you a stack trace. If I expand down my query analysis, it's going to give me very detailed information about maybe some things I can do to improve the performance of my database queries. Okay, then I quickly want to talk about errors. We haven't touched on errors yet. So New Relic is going to alert you based on a couple different items. Could be based on apdex, it could be based on a threshold that was set for your server monitoring, or it could be based on an availability threshold. We alert on error percentage rate. So if you have one error, I'm probably not going to get an alert on that, but if you have multiple errors over any point of time, we'll start to alert you based on the threshold. And the nice thing is here, we're going to give you a graph that shows you, or a table I should say, that's going to show you what errors you're getting, what the message was, and what the total count was. If I drill down into one of these errors, it's going to give me a stack trace. And the nice thing about the stack trace with the errors is that we're also going to capture the request parameters. Again, that's to help you debug. And we're also going to capture any custom parameters that you've chosen. So we've covered so far going from a very high level, looking at our application server. We understand that data is an average and aggregate. We see some type of issue, then we can drill down very quickly into a waterfall chart, look at our slow sequels, look at stack traces, and get kind of right to the issue. So we covered the app server, we covered the server monitoring. So let's take a look at what the data would look like from an end user's perspective. And again, as I mentioned before, we can start anywhere, but we're always going to get back to the same place. So what we're looking at now is data from the end user perspective. Now, if you remember earlier, I mentioned we inject a little bit of JavaScript, and that's how we grab the data. We grab the data about the overall application performance. So from here, I could drill right down into my application. I can see the metrics around my network, how much time was spent on the network. I can see how much time was DOM processing. Essentially, DOM processing is downloading the HTML, parsing the style sheets, and parsing the JavaScript. And the page rendering is grabbing the rest of the static assets for that page. Same UI layout. As I hover over in context, my entire graph changes. One nice thing I haven't showed you is that being able to drill down, if I have a spike, I can drill down right here from this graph. I can expand, or I should say, narrow down the time frame and drill directly in. But before I do that, it's important to note the apdex score on the top right-hand side here is set to 2.4 seconds. By default, as a new user to New Relic, it's going to be set to 7 seconds. And when we did the math on the apdex, it was the t-value times 4. So your frustrated user threshold is going to be set to 28 seconds by default. If you've been to a web page, that's a pretty long time for a response. So again, we always encourage you to lower that threshold, and that's what's going to drive you for continuous improvement over time. Okay. A nice thing here is we see the web browsers that are coming through. Just a quick note, depends on what type of browsers you're targeting. You may be targeting your application to perform in IE9 or to perform in Chrome, running on Mac. So we give you those statistics about what browsers the end users are using. And again, you can sort this data any way you want. When I think about performance, I want to know what's slow. I want to know why is it slow. And then is it slow for everybody? Okay, so I can see here that the average front-end load time is the longest is on Firefox, but then I can sort it and say, well, does that have the highest amount of throughput for me? So again, I'm not going to spend a lot of time here, but this is quickly to show you if you're developing towards the right platform that your end users are accessing the application with. And then tying back to the web pages. So the web pages are going to be tied directly back to the application. Since the application is, the agent is naming the web transaction, those are going to propagate out to the end user side. And we'll start to see some common names here. The application controller show, the application show. If I, again, tap on any one of these, it's going to change the context into this one view. And on the right-hand side, I'm going to have data related to that view for my web application, time in the network, time DOM processing, and page rendering. And again, I have the same availability here to sort by throughput or to sort by the average page load time. So in this example here, I'm just going to pick on the controller view. And you'll notice on the right-hand side, we have the app server drill down. So it's nice that we get end user data. We know where they're coming from. We know what type of browsers they're using. And now I know that on this particular page, there's some type of performance issue. Well, the nice thing is I can click on the app server drill down. And what this is going to do is this is going to bring me right back over to my application side. And now that I'm back on my application side, I understand that there was an end user that had a poor performance experience. And I can drill right down into this, in this case of Ruby, the specific controller. And from here, I can drill right back down into my, my diagnostics component and start to see exactly what was going on. Again, my request parameters, my custom parameters. Okay, it shows me the instance. It's going to show me the response time, the date, all the information I need to start debugging this issue. Okay, so hopefully you see how we can tie the data from the app server all the way down to server monitoring, and then from the end user back into the app server. And I just have a couple reports that I want to touch on really quick here. We have the SLA report. Again, I'm a fan of SLA because it helps drive continuous improvement. The SLA is really based off of the AppDex score. So if I highlight my AppDex score, I can see on the bottom here how I'm doing visually. Now it's broken into two components, the end user and the app server. Okay, and if I look at my page views over, this is over a running 12-week period, so I can start to see I had 4.8 million around March, and then went to 5.5, 4.7. So I can start to see a steady increase of traffic. If I look at my AppDex score, I start to see a decrease, which is not good, right? We want to increase our AppDex score. We want to keep it at a high value. So we had some performance issues on our end. We had one of our engineers go in and make a lot of changes to the way that we process pages and serve them out. And you can see we went from a 0.8 to a 0.6 to a 0.7, and we're continuously getting better. So that's just one example of how you can use New Relic's SLA report to help drive the continuous improvement. So you look at the SLA, go back, see that your AppDex score may be going somewhere where you don't want it to go, then you could start going in and analyzing your data from the application overview, from the end user overview, and then start working through the issues that way. And again, one last note on the SLA report here is the amount of frustrated users, right? We want to keep that level of users low because frustrated users tend not to come back to the site. And again, the SLA report's available on both end user tier and application server tier. Going directly into availability, because that's something that I mentioned that I wanted to talk about up front, you can see here that our uptime is 99.93%. So I'm going to drill down into one of these here. Now our availability monitor is very simple. We basically perform a GET request from one location just to tell you whether the application's up or down. There's a couple of nice things about the availability report. Even though it's very simple, it's coming from one location. If we do notice an outage, we're going to basically take a snapshot of that page, present it back to you. You can go ahead and be able to drill into that page. Okay, so it's going to show you what we saw. If it was a maintenance window, you can go ahead and flag it as maintenance right here. However, if it's a legitimate issue that you need to deal with, you can go view the application performance for the prior 3 hours to that outage. Okay, so I'm going from just understanding basic availability, I can flag it as maintenance, and then I can drill back 3 hours prior to see if there was anything that led up to that. Okay, and I know we're running out of time here, so I had one more report, and actually a feature that I think is important when we call the deployment markers. Now I think of a deployment marker as a bookmark. We give you the ability to send us a request over to the New Relic servers virtually for anything. If you made a hardware change, if you deployed code, if you changed drivers on your machine, you can send over that bookmark. So what happens is when you send that bookmark over, it's going to show up in your graphs. You may have seen them earlier. There were green markers that show up throughout your graphs. And then what we do is we keep a running tally of the deployments. So I can start to see from an end user perspective what my deployment looked. We had a deployment actually yesterday. How is it looking to the previous deployment? And the same concept from the app tier. Now these deployment reports, I can drill down into any one of them. So let me go ahead and pick on this one here, Brent. So we noticed the previous deployment that there was a high error percentage as the deployment was made. So now I can start to see information on the top, who deployed it, what my AppTech score is like, are there any errors after I made my deployment, and then it gives me a graph with some metrics, response time, looks at my overall AppTech score, information about the database and CPU. A couple other important pieces of the deployment report is the ability to keep a change log. So I can see what was changed in this particular deployment, and then I can see what was changed in any previous deployment. So if I make a deployment and there's a high error threshold, I can make another deployment, put my change log in there, and see how I'm progressing as I make my different deployments. Okay, and then I guess the last thing to show here from a deployment perspective is setting this up on your end is really straightforward. What it calls for is, and if you, there we go, okay, so show instructions. So essentially what you're going to do is you're going to make a curl call out to our new Relic servers, and you're going to pass over the information about your deployment. And again, think of it as a bookmarker. It's not just deploying code. It could be any change that you made within your environment, and you want to keep track of that as it relates to your application performance. Okay, so hopefully, I know we went through that fairly quick, and I think I covered the 5 points that I mentioned earlier in the beginning, and hopefully being new users to New Relic, that may shed some light on doing some availability monitoring, looking at deployments, looking at data obfuscation, and actually that's one thing I didn't touch on, so let me take one more second, Amy, there. We forgot about that. Was the data obfuscation. By default, when we collect data from SQL statements, we obfuscate the data, meaning we're just going to show you question marks where sensitive data should be. That's an option for you to turn on or off. And I'll go ahead and pick on one of these, and hopefully we see here. Okay, so if you look at our database query, you can see the in statement, and there's the IDs in there. If by default, you will not see those. They'll all be question marks. But as we all know, depending on what data you pass into a query, it could drastically change the performance of it. So in order to tune the queries or debug them, you can always turn the value to raw. And once you change the value to raw, all this data will show up for you. But by default, we turn it off. Okay, and I think that's all I had, Amy. I was
Thanks, Michael.
Quick.
I know that was quick. I have a ton of questions coming in, which is great. I can unmute you. I'm going to actually start with Aaron and have him ask a question. We're happy to hang out a little bit after for another 15, 20 minutes if you have questions that you want addressed now. If not, please type them in the chat. There's also a follow-up survey. Put the questions in there. Let us know what else you want to hear from us, because we're going to be doing this on hopefully every other week. And probably focus a little bit more on certain things within the application. So definitely bring your questions on. I'm going to go through some of these questions right now. We'll start with Aaron. So I'll unmute you, Aaron, and you should be able to ask away.
Hi. Yeah, we use a tool called NetQoS, which helps to measure the time it takes for packets to get from our app server entry to the time it leaves. And I saw you guys are out, measuring average response time as well. So in order to do apples-to-apples comparison, I was wondering, how can I get the raw data of what you're showing in the graph so that I can extract that into an Excel spreadsheet to compare to see if what New Relic is measuring is a subset of what we're seeing in this other tool, or if it's even close, to be able to compare and contrast, because now we got two different tools measuring what seems to be like the same thing. And we're using the REST API, and there's a bunch of different metrics and fields that you can extract. I'm confused as to which one to use to be able to get that information that you're showing in the tool.
You mentioned you're using our REST API to grab it?
Yeah.
You know, that may be something that we can handle offline, so I don't know every single metric that's exposed in the API, but if we want to sync up offline to do that, we can definitely walk through that to see if that data is available. Fair enough?
Sure.
Okay.
Great. Aaron, we'll follow up with an email and schedule something for you.
Great, thanks.
Got it. Does anyone else have a question that they want to ask right now directly to Michael? I mean, like I said, I'll get through the ones, even if you chatted it in. If you want to ask it to get the answer, I'd be glad to do that now. If so, just raise your hand in the control panel. Okay. Ian, I'm going to unmute you. Okay, you're all set.
Yeah, hi, you mentioned the raw data and the SQL statements. How do we turn that on?
That is if it's in the, depending on the language you're using, it will be either in the YAML file. What language are you using?
PHP.
Okay, so it'll be in the INI file, and there's a setting in there enabling it to raw. It's set to obfuscate it by default. It's actually in the documentation. If you go to newrelic.com/docs, it will come up with the kind of a summary view of the documentation. If you click on the PHP documentation, on the right-hand side, you'll see something called PHP INI settings.
Okay.
That help?
Yeah, and I have one more question, if that's okay.
Sure. Yeah.
So, in looking at the load times of our site, you guys break it down for our purposes. We see web application, network, DOM processing, page rendering. Our web application is pretty flat, well below 50 milliseconds, no issue there. Our network is around 1 second, and then beyond that, DOM is about 1.25 seconds, and page rendering is on average about 1.5 to 2 seconds. And we're trying to understand, how to use that information and where to optimize it. So let's talk about page rendering for a second. What are you measuring in page rendering, and how can we use that data to improve delivery to the customer?
So page rendering is basically measuring the static assets on the page. I actually have a great article. I don't know, when I was going through and I showed you the SLA report, you saw that we started to have a pretty big impact on our AppDex score for performance. And
which SLA report are you referring to specifically?
The SLA report that I showed while we were going through the presentation. It basically showed that we had a pretty big performance hit. What one of our engineers here in R&D did is he wrote a blog about it. And to your question specifically, he broke down how we used page rendering. He broke down how we used DOM processing, talking about, we used jQuery, how he compressed jQuery, where he loaded it on the page to get, I think it was over a half a second performance improvement. And that's something that I can share with you guys. It's on our blog site, and it's in detail of how to use it.
Can you post a link to that in the messaging queue?
Yeah.
Can you find it quickly? If not, I can send it to you in an email follow-up for sure. I just jotted a note down.
Yeah, that'll be great. That's fine.
Okay.
And then that also covers the other areas of the graph, correct? Like, for example, networking.
Yeah, that's all going to be in there. The networking measurement, how we calculate the measurement, that's in the RUM documentation. I'll send you a link to both.
Okay, that's fine. Great. Thank you.
Yeah, and then let us know if you have more questions after you receive that.
You got it.
Great.
Where can I post that link?
All right, I'm gonna unmute Jeff next. All right, Jeff. We can't hear you.
Can I post that link?
Yeah, I can. You can chat it to me and I can send it. Jeff, are you there?
Oh, Steve posted it. Okay, good.
Nope. Okay, I'm gonna come back to you, Jeff. Joshua, I'll unmute you. Okay.
Hi.
Joshua.
Hi. I had a quick question I asked in the chat about what constitutes separate applications, and you can respond to me offline about that. I had a specific question about we use Java, and I was wondering, do you have any experience? Was there anyone used automated deployment tools to automatically notify New Relic about deployments with the REST API or something like? For example, I'm thinking about using Cargo to do automated deployments to our Tomcat instance. Is there anything that, have you ever seen anything that automatically hooks in and notifies New Relic about the deployment?
Steve, you have a little more.
Can you guys hear me?
Yeah, we can hear you.
Oh, okay. Yeah, we do. Actually, the way you do deployments is through an external command. You can issue it through curl or even wget, I believe, or something of that nature. Even use our Java agent. The Java agent has a built-in command to issue deployments. So, yeah, providing you have a way to add a command line call to your script. I can't remember what you said you're using, but that's exactly how you issue the deployment markers.
Okay, great, thanks.
Okay. Let me go back.
And guys, hey, we may want to send the gentleman who just asked a link to the page that shows how to set that up.
Yeah, I can do that.
Okay. And that was Joshua. All right. And I'm going to apologize if I say your name wrong, Tagore. I'm going to unmute you. Are you there?
Yeah, I'm here. Can you hear me?
Okay.
You're slightly close.
Okay, how do you pronounce it?
Sagar.
Okay, sorry about that. Thank you.
Well, my question is, we use LAMP stack, so I've deployed in the PHP agent. You mentioned a little bit about Drupal and WordPress. Is there a way to actually separate those stats based on those applications? Like right now, what I see is just a PHP application in the applications dashboard. Is there a way to actually separate Drupal versus WordPress versus any other PHP-based applications?
Do you have them running as virtual hosts?
Yes.
Okay, so there again in the documentation it explains how to do it. We have a setting for PHP called per directory, and what that'll do is when you configure that the way it's supposed to be configured, what's going to happen is as your applications show up, you see in the UI here how we have all the applications listed out. It'll basically break out those applications with whatever name you give it for that particular directory for PHP. Make sense?
Yeah, absolutely. So
okay,
just
again, I think even if you go to documentation and search for per dir, it's going to bring that page up for you.
Okay, sounds good. Thank you.
Great, thank you. And I'm going to go back to Jeff and see if we can hear him this time because he is the last we have so far. Jeff, are you there? Nope. Okay. Does anyone else have any other questions? Again, if you just simply chat or raise your hand, I can unmute you. Oh, it looks like Adam. All right, Adam.
Yeah, I had a question about upstream caching and if there was any way that you could incorporate that into the app decks. We're really interested in using Varnish, and effectively it would sit in front of our application layer and actually serve requests that had a certain cache time that hadn't expired. So obviously there would be requests that didn't make it all the way. We're using Django on Apache, and so we would have requests that didn't actually make it all the way down to Apache, and I was just curious if there was any way to integrate that in with our app deck score.
Steve, you got that one?
Yeah. The way we handle the caching layers like that, that'll be reflected in the end user app decks. Obviously, it won't, since the request isn't going back to the server, we won't be measuring anything on the server side component, but it should be getting calculated and be reflected in that end user app decks.
So if I say that it's a RESTful API built with Django and there's no JavaScript that's getting passed over, does that change?
Oh, okay. I'm sorry. So yeah, if it's not an actual page, we actually don't collect end user data for just pure AJAX calls or anything that's not page based like that. So we're working on a solution for that. So you're talking about going back and hitting a caching layer for a chunk of JSON data or whatnot that you're just returning back to a page?
Yes.
Yeah, that's, gosh, that falls into kind of the crack in our two solutions. We don't, I'm just thinking, I'll have to check with engineering to see if we have a way to track that, but just in the base configuration of the agent with the way things are set up, we are not going to be able to really break that out and give you a number on that.
Is there any way that I can push information to New Relic, like if I wanted to consume the logs from that caching layer myself and push it back?
Yeah.
Something other than the agent?
Yeah, that's what I was going to check with. I mean, we do have a way to do that. It's still a JavaScript approach, but if for instance, if you in your page load, if you can time something like, yeah. I can't tell if somebody's asking for get some noise in the back. Anyway, there may be a way to do that with a API call. It would require executing a JavaScript post a timing metric back to our beacon process.
Okay, awesome. Thank you.
Yeah.
And Adam, if you want some more information on that, my email, you can just drop me a note and we can follow up and schedule something.
Yeah, Amy, if you don't mind, just remind me and I'll send you a link to the.
Yeah. You got it. All right. Thanks, Adam.
All right, thank you.
And then it looks like we have another question from Todd, so I'm going to unmute you. Okay, Todd.
Hi. We recently launched a bunch of performance tuning, and it seems to be working great, but we also had a giant spike in our DOM processing. It went up by, it went from about half a second to a second and a half, and we didn't dramatically change our HTML or CSS, and I'm just wondering what might have caused that spike, including if maybe third-party calls to JavaScript that actually adds content to the page could have affected it.
You know, that is possible, but I think a gentleman asked me a question earlier, a similar question. And I have an article that I'm going to post for you guys just in a few minutes here. Actually, it's up in the chat window. And if you look at, Steve posted it. If you look at that, it explains how our engineer, mostly with the DOM, what he did to increase the performance, and some of that stuff that he did to increase the performance is what you were talking about. And that may be very helpful.
Hey, Michael.
Yes.
I guess part of the question is just because of the spike in DOM processing, it looks like our page performance stayed the same even though we sped up our pages quite a bit. So I'm trying to figure out even if there's a way of filtering out the post-page load processing, because the user experience has actually gotten better. Does that make sense?
So you're trying to filter out just the page request, page processes?
Well, I'm trying to get a view on our data that doesn't include this spike in DOM processing, because we actually sped up our pages, but it was the speed up was counteracted by this spike in DOM processing that I don't quite understand.
So you just wanted to see just the app performance?
Yeah, or have that be our AppDex scoring if there was a way of.
Oh, I see. Yeah, you know, currently we can't separate out the individual values like that. I mean, we can pull out like individual transactions, but to take just a part of that end user value is going to be not going to be possible right now, like you're describing.
Okay.
Good question. I mean, if you just want to view it in the UI, you can actually click on the labels for those graphs, and it'll turn off the individual segments.
Yeah.
But yeah, that sounds like that's not really what you want. You want to do something else with it, which is calculate the AppDex value. Hey, what I wanted to say though, Michael and Amy, is that those links that I posted, those just went to you guys. You need to repost those to the team. I can't seem to be able to post to them.
Nope, I did actually. So everyone should have received them, and then I can do a follow-up as well to everybody. So absolutely, I did post them though. All right, that was the last question I at least see with a hand raised. I do have all the typed in questions that we will address separately. Looks like we're good. Oh, Ian, I'm not sure if you just raised your hand again, so I'm going to unmute you and find out. Are you there?
Thanks, I did. Just a quick question.
Yeah.
You talked about the custom parameters. You got any documentation on those?
There sure is. There's what language are you using?
PHP.
Yeah, there's lots of documentation. Again, newrelic.com/docs.
Okay.
And I believe it's on the right-hand side when you go into PHP. It's grabbing custom metrics, I think, is what it's under.
Okay, I'll take a look. Thanks.
Okay.
Great.
Hey guys, I got one last follow-up answer. There was the very first question was I don't know if the gentleman's still on the line, but he had asked about comparing our average values with another tool. And one easy way he may want to do that, if he doesn't want to have to continue to work with the REST API is on the web transaction screen itself. There is an option to see all the web transactions in a table view, and that lists all of the different metrics that you can get with the REST API, but it's just much more convenient. And they're listed in a table view. It has the average, the max, the min, and so forth for each one of the transactions. So that may be an easy way for him to, just set the time frame for what period you want to compare against, and then you can, find your transaction. You can even export that table into a CSV file if you want to pull it out and put it into a spreadsheet format.
Great. All right. Thanks, Steve. All right. Well, we're at that hour mark, so thanks for hanging a little bit longer with us. And again, you'll get some other responses via email, and I may actually try to put a whole bunch of questions together and send it out to the entire team too with those answers. So feel free to follow up via email, and you have all my information. And thanks for your time. Thanks, Michael and Steve.
Thank you.
All right.
Thank you. Bye.
Bye.